already learned about symbolic relations and separation of symbols. And in our previous lessons, we've learned about how to prove for a symbolic relations. And now we are going to learn about methods of separation of symbols. Methods of separation of symbols. So we are going to have an example, and we are being told to show that this whole, or this one, this is the forward difference operator to power n having a functional value with x minus n is equals to all of this. So we are being asked to show that this one is equals to this, or whatever is in the left hand side is equal to whatever is in the left hand side. So we are going to prove. We are going to have a proof here. So to prove this, I love writing in words so that you can understand. To prove the result, we start with the right hand side. So thus we have whatever is in the right hand side is from the is equal sign going to the last value here. So we have ux. This is not an averaging, it is just a functional value. Ux minus nu, we have x minus 1 plus n into n minus 1. We are writing whatever is in the question, divided by 2 ux minus 2 plus negative 1 n ux minus n. And before we continue, remember, this is a short NB. I love reminding my students about this. We have the general equation for the shift. When we are talking about symbolic relations, we said that the general formula for shift operator is En, functional value yr is equals to yr plus n. So this is the functional value. Here we are using y, but now here we are using u. Relate the two. So we have, wherever we have ux minus 2, ux minus 1, we have x. It means that it is being represented by the functional value yr. So we have is equals to ux minus n. We are going to represent this with the shift operator e. So we have e, and remember we said that to have the power of shift operator is in the functional value. So for example, this is yr plus n. It means that the value, or the power value of the shift operator is what is the function of. So this one is n. So here we have n, and in our case here we have e. This is, we are going to represent this with shift operator. So we have n e to power negative 1, because in our functional value we have negative 1. Then we have ux. Are we together? Plus n minus 1 divided by 2. We replace this with the shift operator e to power negative 2 ux plus we have negative 1 to power n. We replace this with the shift operator e. We have e to power negative n ux. So are we together up to that point? Then we say is equals to 1. So we are going to put ux as the subject value. So we have 1. So we remove ux, we have 1 minus n shift operator negative 1. So this one we are going to have it as a subject method, or the subject value, plus n minus 1 in negative 2 divided by 2. plus negative 1 n shift operator negative n multiplied by ux. So when you open all of this, when you work out all of this, you're going to have 1 minus e to power negative 1 n with the functional value ux. So then we have, putting this one as a fraction, we have 1 minus e. The reciprocal of this is 1 over e. So we have 1 over e. Let's write it well here. We have 1 minus 1 over e. Are we together? Then we have n ux. The reciprocal of e to power negative 1 is 1 over e. So in this case, we are going to employ the method of LCM, that is the largest common divisor. So we are going, the LCM of this is e. So e divided by 1 is e times 1 is e. So we have e minus e divided by e is 1, multiplied by 1 is 1. So we have 1 n ux. Are we together up to that point? So when we are learning about symbolic relations and separation of symbols, we say that e minus 1 is equals to, let's write here, we say that e minus 1 is equals to forward difference formula. Are we together? Have we remembered about that? So we are going to replace this with the forward difference formula. Okay, so we are going to have forward difference operator divided by this e shift operator, because it is being raised to power n. Then we have ux. This is the function value. So we are going to have this forward difference to power n divided by the shift operator to power n multiplied by ux. So we are going to write, our equation will be forward difference operator to power n. When we put the reciprocal of this, we have multiplied by e to power negative n ux. Are we together at that point? So our answer will be forward difference to power n multiplied by, when we write this in the form of, you remember, we want to change from the shift operator to the form of functional value, and we have, so when we want to write e or the shift value to power negative n ux, this will be e to power negative n ux is equals to, we have ux minus n. Are we together? So we are going to write the forward difference operator to power n multiplied by ux minus n. This, which is the left hand side. So this is what we have here.